Okay, guys. Today let's see Terraform scenario-based questions. Okay. So first scenario. Okay. So you want to have a zero downtime deployment on a EC2 instance. Okay. So you need to update the EC2 instances AMID. We will have the AMI IDs, right? So we have to update a new AMI ID, but we shouldn't have downtime. Okay. So Terraform normally how it will do, it will destroy and then it will create the instance when you update the AMI. So how to avoid this downtime? So when you want to avoid downtime, you have to use the life cycle. Okay. So in the resources, you are giving AWS instance and then name and then AMI ID and then instance type. And then when you want to change this AMI ID, normally it will delete and create. In case if it doesn't want to create, delete and create, you can use this one. Okay. When you mention lifecycle, create before destroy equal to true. So it will try to create a new instance before it tries to delete the existing instance. Okay. So this ensures to new instance is created before the old one is deleted. Okay. So this thing, in case if you want to have zero downtime, you want to use create before destroy. Okay. And next scenario. Okay. Managing cross region infrastructure. So you need to deploy a S3 bucket. Okay. One in US East one. And you also want to deploy an EC2 instance in AP South one. Okay. So we have two different regions. So how you can deploy cross region infrastructure using Terraform? So you have to provide multiple provider configurations. So there is no need of mentioning a single provider always. You can configure multiple provider. So first you can give provider as AWS and you can give alias. Okay, there you can define US East one. Again you can define like another provider and then you can give alias. Okay, so that what happens, so when you define the resources S3 bucket, you can select the provider as aws.us east us east, and when you create another instance you can give aws ap south. Okay, so that what happens, so based on this alias, so you will be able to create different instances like S3 in one region and EC2 in different region. Okay, remember this one alias. Okay, this is very important. So, handling Terraform drift in production. So, what is drift? Drift means actually, in case if the environment which is defined in TF file, if it is changed in the current environment, then there is a drift. Okay. So, what is the question? So, your Terraform managed AWS infrastructure was modified manually by another team. Okay. Terraform does not show changes, but the AWS console does. Like in AWS console, you are able to see the changes, but not in the Terraform. So how do you detect and correct this? So first, in case if there is a change in the environment, but it is not in the Terraform files, then you have to do Terraform plan refresh only. So what it will do, it will refresh the state, okay, to detect the drift. And then you can use Terraform state list. So it will inspect all the resources. Okay, so if a resource is missing, you can use import. Okay, so some in your Terraform file, you don't have particular resource. For example, some VPC or EC2 instance is additionally created and you are not able to find it in the Terraform file. So what you can do, then you can use Terraform import and then AWS instance, and then you have to give the name and ID. Okay, then when you do this import, that ID will be automatically imported into the Terraform file. Okay. So enforcing Terraform security policies. So your company wants to ensure that only T2 micro instances are used to control the AWS cost. So how do you enforce this in Terraform? Okay, so like in case if a user is trying to create an EC2 instance, you will be able to create only T2 micro. Okay, you will not be able to create any T2 nano or T2 medium, T2 large, anything you will not be able to create. So in case if you want to restrict user only to create T2 micro, how you can define? So you can define it under validation. Okay, so under validation, normally you have to use Terraform validation rule. Okay, so we have to provide a configuration called validation under variables. In case if you have defined variable as instance type, you can define validation and condition. In the condition contains T2 micro. Okay, so it should always contain T2 micro. In case if it is not there, then it will throw error. Okay, so you can define error message like what error message it has to display. So only T2 micro instance is allowed. In case if you want only T2 medium, you can define condition equal to contains T2 medium. Okay, so that it will only allow T2 medium. Similarly, like whatever configuration you want, you can define it under validation section. Okay. So the next scenario is blue-green deployment. So you want to do blue-green deployment using Terraform for an auto-scaling group. So how you can achieve it? So actually, in case if you have to do blue-green deployment, you should have two environments, right? So what you do? you can use auto scaling group. One is blue and another is green. Okay, you can place this auto scaling group behind load balancer so that traffic will be spread equally. Okay, so how you can do? So first you have to create two launch templates. Okay, one launch template is for blue and another launch template is for green. Okay, then you have to configure two auto scaling groups. One auto scaling group is for blue and another auto scaling group is green. Okay, then you have to like define all these auto scaling groups inside this load balancer. Okay, and then in you will have these resources in Terraform file. Uh, like you have to define these target groups. Okay, in the target group you have to define AWS LB target group here green. Okay, in case if you have to define it in green, you have to define green. In case if you want to deploy it to blue, you have to define it as blue. Okay, so that it will be split. Like in case if you want to drive out traffic only for one auto scaling group, you can define those things inside this action block. Okay. So next, like Terraform apply failure. Okay, so you are creating 100 plus AWS resources in a single Terraform apply. So you have a single file. Like you, let's consider you have single main.tf file, and then you are creating hundreds of resources. So here we have mentioned just five resources we have mentioned, right? Similarly, you are mentioning hundreds of resources. Okay, so what it happens? You apply Terraform apply, but process fails due to AWS API rate limit. Okay, how do you fix that? So in case if you are creating hundreds of resources and if it is not accepting, I mean it is failing, then you have to use retry settings. Okay, when you set the retry settings, it will try. In case if there is some temporary issue, it will retry, so that in case if that issue is fixed, it will automatically continue to the next step and it will fix the issue. Otherwise, in case if like if it is not working, then you can use depends on. Okay, so for example, you have hundreds of resources. Here we have AWS launch template and then AWS launch template. Okay, so auto scaling group is dependent on this launch template, and then this load balancer requires this auto scaling group. So one instance is dependent on other, right? So what you have to define? You have to use depends on. Okay, so when you use depends on, once the instance one is created, then the next instance will create. Okay, so here if you see the example resource. Okay, so they are creating EC2 instance 1 and then EC2 instance 2. So here what you can give depends on AWS instance 1. So when you give depends on, first this instance will be created. Once this instance is created, then only it will create the second instance. Okay, so what you have to use? You have to use depends on. Okay, preventing accidental deletion. Okay, for example, you have some high critical applications. Okay, so you want to prevent an accident deletion of like high critical database. Okay, managed by Terraform. How do you enforce this? So in case if you want to prevent it from someone like unknowingly do Terraform delete destroy, it may delete, right? So how you can prevent that one? So we have to use lifecycle. Okay, so under lifecycle we have to use prevent destroy equal to true. So when we give prevent destroy equal to true, in case if you want to delete something, it will not delete. Okay, it will tell like it is blocked due to this life cycle and it will throw an error. Okay, managing multi-tenant AWS accounts. Okay, so in case if your organization is having multiple AWS accounts like dev, QA, prod, how do you manage deployments efficiently? Using Terraform workspaces. Okay, so you can create separate workspaces for dev, prod and staging environment, and you can create separate configuration files. Like you can have single configuration but in separate workspaces, so that you can have separate Terraform state files as well. Okay, so you can have same configuration and you can just modify the Terraform variables, so that you will be able to maintain different environments. And handling Terraform state locking issues. Okay, your team is using Terraform with remote state in S3. A team member's Terraform run failed, leaving the state locked. How do you resolve the issue? So what happens, like normally we will have Terraform state files. Okay, so if someone deletes the Terraform state file, then actually the environment will be corrupted, because the Terraform, it will not know like what are the resources it has created. Okay, so how we can fix this one? So we can fix that one using S3 bucket. Okay, so what S3 will do? S3 will be connected with the DynamoDB, and actually it will lock the state file. Okay, so what does happen? Like in S3 you will have a backup, and then if two or three members are trying to modify the same resource or something in your Terraform environment, mostly the Terraform state file it will be corrupted. Okay, in order to avoid that one, we will be locking that one. Okay, so that no one will be modifying, like in case if one person is modifying, others cannot modify. So how you can achieve this lock? By configuring some DynamoDB. Okay, so in case if someone is trying to modify this Terraform file, but the state file got locked. Okay, so how you can resolve this issue? It's like how you can remove that lock. Okay, so Terraform automatically locks the state in DynamoDB when using Terraform backend S3. Okay, if lock persists, run Terraform force unlock. Okay, in case if you want to unlock that locked state file, you have to run Terraform force unlocked. Okay, and you can list the state files, and then it will show the state file status. Okay, so what is this? Like in case if you want to take a backup and for Terraform state file, you can use S3, and to enable the locking, you have to use DynamoDB. And in case if it is locked and if you have to unlock, you have to use the command Terraform force unlock. Okay, and then you have to give the lock ID so that it will be unlocked. So rolling back a failed Terraform deployment. Okay, your Terraform apply modified resources incorrectly, causing an outage. So how can you quickly roll back to the previous state? Okay, so you've done Terraform apply, but instead of modifying some test or dev environment, it has modified in the production, and it is causing some issue. Okay, so in case if you have modified, then actually Terraform state file will also be updated, right? But what you can do, if you have a previously state file stored in remote S3. So in case if you have the state file, normally state files we save it in S3, right? So in S3, in case if you have enabled versioning, so what we can do, we can just pull that Terraform state file backup. Okay, so we will be having this one. Okay, Terraform state pull backup, and then we can state push Terraform state push backup.tf state. Okay, so using that old tf state file, you will be able to roll back the changes. So you can revert the incorrect code and apply Terraform again. If necessary, manually restore critical resources before running Terraform apply. Okay. So what you can take the backup which is available in S3, and then you can try to rerun it. Okay. So that the state configurations which were there earlier, you can restore those things. And then the next scenario is dynamic resources scaling with Terraform modules. Okay, your infrastructure requires different EC2 instance types. Okay, based on environment like dev prod. So how can you dynamically assign instance types in a Terraform module? So use Terraform TFRs. Okay, so what happens in case if you want to like give different EC2 instances inside the variable, we can give a variable name and type like a mapping string. Okay, so you have to give map a string, and by default you can give dev as t2 micro and prod as t3 large. Okay, so in under the variable section, you will be able to define different environments. Even if you have stage, in case you can define stage, and in the instance type which you want, you can define those things as well. So what happens when you create a resource under instance type var dot instance type var instance type map, and then you can give it as dictionary. Okay, so what it will do, you can give var dot environment. So you can define this dev or prod whatever. So based on that, it will automatically take care. Okay, so managing secrets securely in Terraform. Okay, so your Terraform code requires AWS credentials. Okay, so normally in case if you have a Terraform code, in case if you are deploying it in AWS, Azure, whatever it is, it will require these AWS credentials, right? So how do you securely manage these credentials without hard coding them? Normally when we have seen demos, we were hard coding it, but that is not what we have to do. So how we can manage these secrets? So normally you can use AWS Secret Manager. Okay, so in case if you are using AWS Secret Manager, you can save the credentials there, and you can dynamically access it whenever required. Okay, so you can define it under data AWS Secret Manager, and then you can just pass in as variables. So for example, if you have created a secret called mydbcreds, and under secret ID you can pass this variable. Okay, from there it will be able to access. Under resources, in case if you have AWS instance, just give the username password, and then you can pass this data AWS secret version db creds, and then you can pass in the secret id. So normally, in case if you want to manage these secrets, you can use AWS Secret Manager, or else we can also have one more option. Like in case if they are using Terraform Vault, they can use that thing as well for managing the credentials. So managing large Terraform state efficiently. Okay. So your Terraform state file is growing too large. Okay, causing slow performance. How you can manage efficiently? Okay. So for example, you are creating like hundreds of resources, and for example, let's assume you have 1,000 resources. Then how big your Terraform state file will be? So if the Terraform state file increases and if it is of large size, then obviously it will be of slow performance. Okay. So how you can avoid this thing? Use Terraform state splitting. Okay, you can separate resources into multiple state files, and you can use workspaces. So for dev, prod, staging, you can use separate Terraform state files, so that at least the sizes will be reduced. Also, like we have to enable state locking. Okay, store state in S3 with DynamoDB to prevent concurrency issues. So in case if you want to avoid concurrency issues, you can use S3 with DynamoDB. So if you want to take backup, you have to define it under Terraform backend S3. You have to give the bucket name and a key and a region and DynamoDB table. You can create a DynamoDB, and you can create a table, and you can give the name of the table here. Okay. So auto scaling worker nodes in EKS. Your Kubernetes cluster runs on AWS EKS. Okay. How do you configure Terraform to auto scale worker nodes dynamically? So what you have to do, you have to configure a auto scaling node. So how you can configure? So you have to define it as a resource, AWS auto scaling group, and you can give the name as EKS nodes. You can define minimum in size and max size and decide capacity, and you can give the tags in case if you want to just give the keys and values. You have to just pass it here. Okay. So these are tags just for the reference. By giving these things, you will be able to create the auto scaling group, so that once the auto scaling group is assigned, you can manage the EKS nodes automatically. Like dynamically, it will be able to increase and decrease. So avoiding resource recreation in Terraform. Okay, you updated an EC2 instance type, but Terraform wants to destroy and recreate. So it, instead of modifying it in place, how do you prevent it? Okay, so like in case if we turn to like without destroying, if you want to create, so what you can do, you can use ignore changes. Okay, under lifecycle, click like you have to define ignore changes, and then you have to type instance type. So if you are passing instance type, so here is the instance type, right? So whatever you give here, okay, if now it is T2 micro. So in case if you change it to T2 medium, T2 large, whatever it is, this Terraform, it will not consider as change, and it will not avoid these things. Okay, in case if it want to avoid this one, then you have to define lifecycle. Okay, under lifecycle, you have to define ignore changes. Okay, so by this way, you will be able to like avoid destroy and recreate of instances. So if you have seen, so we have some key points in each and everything. Okay, so downtime means you have to give the life cycle, create before destroy. Okay, just remember this one, create before destroy. And managing cross region replication, you have to pass alias. In case if you want to deploy it in multiple regions, you have to define alias. And then drift detection, in case if you want to find the changes between current environment and the Terraform state file, then you have to do Terraform plan refresh only, and Terraform state list, so that it will list the changes which are there. Okay, and enforcing security. So in case if you want to enforce security, you have to pass in validation. Okay, this is condition, like we have to pass validation under variables. Okay, and you have to pass in the condition. And blue green deployment, in case if you have to do blue green deployment, you should have two environments. Okay, two auto scaling groups, and then two templates, and one load balancing. And Terraform apply failure. Okay, so in case if you have a API rate limit, then what you can do, you can uh, you can give depends on. Okay, you can mention as depends on, or else you can also use retries. Okay, max retries equal to 5. When you do retry, if any of the resource creation failed due to some issue, you can make it retry. Also you can define depends on. Okay, when you give depends on, first the instance will be created, then again I like once the first instance is created, then the next instance will go ahead and create. Like both will not be created at the same time. And preventing accidental deletion. In case if you want to prevent accidental deletion under lifecycle, you have to create uh, prevent destroy. Okay, so that automatic like accidental deletion of any resources can be avoided. And then managing multi-tenant, you can manage it using workspaces, and handling Terraform state locking issues. So we have to use S3s to store the Terraform state files, and DynamoDB for locking the state file. Okay. Rolling back a failed state, you have to get the backup which is saved in S3, and then you have to apply it. Okay, so that the changes can be reverted. And then dynamic resource scaling. So in case if you want to dynamically scale the resources, from different environments, you have to define those things here, and you have to pass in the var.environment. Okay, so here in case if the environment is dev, it will use T2 micro. If the environment is prod, it will use T3 large. And managing secrets securely. In case if you want to manage the secrets, you can use AWS Secret Manager, or else you can use Terraform Magic Vault. Okay, and managing large Terraform state files. So in case if you have large Terraform state files, you can use workspaces so that you can have different Terraform state files for dev, staging, and prod. Also, like you can use locking. Okay, so that it will prevent the concurrency issues. And auto scaling worker nodes in case. So in case if you want to create a uh, auto scaling group, you have to use auto scaling group, and then minimum and maximum and desired capacity. These things has to be given. And in case if you have to avoid resources recreation, like destroy and create again, you can ignore it. Okay, how you can ignore? Under life cycle, you have to pass in ignore changes. And then in case if you want to avoid AMI, you have to pass in AMI. If you want to avoid instance type, you can pass in instance type. Okay, so that you will be able to avoid this destroy and recreate of the resources. Okay, guys, that's it.